Hey, hi everyone. Let us discuss the status 244 contest problem. Dividing by 2. Yeah, you have an array of n integers in one operation. We need to do the element with the floor division. So we need to find the minimum number of operations to make all the array elements equal. Okay. Let's take this example. Definitely we need to, for this stage, definitely we need to try to equalize the elements to 4 because the 4 is the smallest element. So we can't increase the any element because the no operation is provided us to increase. So let us decrease the 8 by 2 which is equal to 4. 9 by 2 which is equal to 4. 23 by 2 which is equal to 11. Hope I am correct. Yeah. So here we got the new elements. Let's write the elements 4, 4, 4, 11. Again we need to perform one more operation on the 11. So if we perform on the 11, we will get the array 11 by 2 which is 5. Again we need to perform the operation 4, 4, 4, 5 by 2 which is 2. So here our target changed, we need to make all the elements to 2. So let us write them in a sorted order. Two is normal. We need to make 4 by 2 which is 2 and then 2 and finally we got the array. Just we need to count the number of operations required to make all the array equal elements. From here onwards we no need to make, right? It's a, if we perform normally only, it is static. There is no greedy thing to choose the which operations makes the minimum elements. Every time we will try to equalize the remaining elements to the smaller elements, so that will give you us the best answer. Okay, we need to what here we are doing, we are sorting the elements and again we are checking that if it is not equal to the smaller element, again we are modifying it to the by 2 and again we are doing. Coming to the constants, here we have a is equal to 1e9 which will be come to 1 in worst case log of 1e9. So it will take 18 operations maybe. Okay, we need to perform for every element, right? So it will be n log 1e9. If in what case every element is 1e9, so n is 100 only, so 100 into 1e9. Okay, to make these many operations, these coming to, if we estimate the time complexity, it is very less. Here we can write any brute force idea. We can use priority queue. Every time it will be giving us the maximum element. We can compare it with our minimum element, or else every time we can sort the array and we can check with the minimum element. So everything is fine because here the constraint is very small. Let us go take the priority queue. Let us read the test cases. They are going to give us vectors. Let us take the many elements. Let us take the mini element to int max. Let us read the element one by one. Let us initialize the priority queue which will give us maximum every time. Let us push into the priority queue. We can perform until every element is equal to the current minimum element in the container. So while pq not empty and pq dot top not equal to mini, we can perform the operations. This is the thing we are doing here, right? If the maximum elements is not equal to the minimum element, we need to perform an operation. So let us initialize the answer. We need to perform an operation. Here we will take the top element and pop it. Okay, here we will do one operation which is val by 2. So again we need to update our minimum element. If the current element is becoming min, we need to take care about it, right? So mini is equal to min of mini comma val by 2. Let us push it into the priority queue. See out answer. We are getting right. Yeah, accepted. That's it. Thank you.